Imagine a massive passenger jet, its tail scraping the runway in a heart-stopping moment during landing. This isn't a scene from a disaster movie. It's exactly what happened to a Cathay Pacific Airbus A350-1000 at Hong Kong International Airport recently. But here's where it gets controversial. While the plane landed safely after a go-around, the incident raises questions about pilot training, aircraft technology, and the inherent risks of modern air travel. The flight, arriving from Ho Chi Minh City, experienced an unstable approach, prompting the crew to abort the landing and initiate a go-around. During this maneuver, the aircraft's tail struck the runway. And this is the part most people miss. The tail strike didn't occur during touchdown, but rather during the go-around itself, highlighting the complexity of these critical procedures. Despite the dramatic incident, the plane climbed normally and successfully landed on its second attempt, with no injuries reported. However, the aircraft, a relatively new A350-1000, has been grounded for 4 days pending a thorough engineering inspection and repairs. This event has sparked an operational review within Cathay Pacific, with a renewed focus on tail strike prevention technology and pilot training protocols. Tail strikes, while rare, are a serious concern. They happen when the rear underside of an aircraft contacts the runway due to excessive nose-up pitch during takeoff or landing. Airbus data reveals a startling statistic. 65% of tail strikes occur during landing, with 25% happening during takeoff. Here's the kicker. Even with advanced technology like pitch limit cues on flight displays and audible warnings, these incidents still happen. Airbus and Boeing have implemented systems to mitigate the risk. Airbus integrates pitch limit indicators on the primary flight display below 400 feet and audible pitch alerts when pitch exceeds safe thresholds. Boeing's Tail-Strike Protection system, introduced on the 777-300ER in 2003, automatically adjusts the elevator during takeoff if excessive rotation rates are detected. Go-arounds, while essential safety procedures, are particularly demanding for pilots. They require precise handling as pilots simultaneously apply maximum thrust, toga, and pitch-up input. Autopilot and autothrust systems assist, but pilots must carefully modulate power and control to prevent over-rotation and potential structural damage. So, are pilots adequately prepared for these high-pressure situations? Commercial pilots undergo rigorous simulator training every 6 months, practicing manual aircraft handling and responses to emergencies like engine failures, rejected takeoffs, unstable approaches, and go-arounds. These simulations aim to reinforce skills beyond reliance on automated systems. During aircraft certification, manufacturers conduct controlled tail strike tests, using protective tail skids to determine the minimum unstick speed, VMU. This critical speed defines the slowest takeoff velocity at which the aircraft can safely lift off with maximum pitch-up attitude. This incident serves as a stark reminder of the complexities involved in aviation safety. While technology and training have significantly reduced risks, incidents like this Cathay Pacific tail strike highlight the need for constant vigilance and ongoing improvement. What are your thoughts? Do you think current pilot training and aircraft technology are sufficient to prevent tail strikes? Share your opinions in the comments below. Stay informed about the latest aviation news and updates by following us on Telegram and Google News.